Hi there, we're going to do the Stoichiometry Lab today. Our guiding question is, what is the percent yield of sodium chloride from the reaction of baking soda and 1 molar hydrochloric acid? Our materials for today, we're going to be using a Bunsen burner, a ring stand, a wire mesh, an evaporating dish, tongs, a scupula, and a balance. For the chemicals, we're going to be using baking soda and the 1 molar HCl in droppers. For the procedure, we're going to clean and mask the evaporating dish and record that value. We're going to weigh out approximately 1 gram of our baking soda and record that value. We're going to slowly add the HCl a few drops at a time until no more bubbles form, and that's how we're going to know the reaction is done. Then we're going to heat the dish on a low flame until all the water has boiled off. And lastly, we're going to weigh the evaporating dish with the NaCl left inside. All right, we are going to carry out the procedure for the Stoichiometry Lab. So first, we're going to take the mass of our clean and dry evaporating dish. So this has been cleaned and dried. And we always want to zero our balance first. Okay, and the mass of our empty evaporating dish is 47.25. 47.25, I'm going to record. And that is in grams. All right. Next, I'm going to put the weigh dish on the balance. Make sure, actually, we're going to put the weigh dish on and then we're going to zero it so that we don't count the mass of our weigh dish. It's about 2.1. All right, so now it says 0. So I have zeroed out the weigh dish, and I'm going to add approximately 1 gram of my baking soda to the weigh dish using the scupula. Okay, I'm just going to open it and put it in there. We're at 0.7, 0.8. And our final mass of baking soda is 1.1. It keeps going up and down. 1.11 grams. 1.11 grams of baking soda. Make sure you're recording these values in a data table. Okay, the next step is to very carefully pour the baking soda into the evaporating dish so we don't spill any of our reactants there. Okay, and you guys can see about how much we have. It's not very much in there at all. And I'm going to pause to put some gloves on before I deal with my acid. Okay, so I'm going to add some drops of my HCl. I'm going to try to do it up close enough for you guys to see the bubbles. And you'll see the baking soda start to, well, it's going to bubble. What gas is being produced when I mix this carbonate with an acid? Do you guys remember? If you said carbon dioxide, you are correct. Okay, let's see if I can get that. There we go. You see the bubbles forming. So the HCl is reacting with the baking soda. And as long as it keeps bubbling, then we still have a reaction going on. We still have reactants left in there. Okay, so you can also see when you're up close and in person that the baking soda, as it dissolves, it goes from a white solid to a clear solution. So I can also tell by appearance when the reaction is over, when all the baking soda is gone. If you guys would like to try a version of this, I'm using HCl because it's more concentrated and it's a faster reaction, but you guys can go ahead and just mix vinegar and baking soda and you're seeing a very, very similar reaction to this. Okay. I hope you guys can hear the bubbling of this. It's still going. We got 1 molar HCl in our approximately 1 gram of our baking soda here. I can tell I'm not very close. There's a lot of bubbles still going on, so I'm just adding a dropper full at a time. As we get closer, it becomes kind of like a titration reaction where we want the two to be equal. I don't want to have a bunch of excess acid in there. So I'm going to slow it down as we get closer to that balance point between the baking soda, which is actually a base, and my hydrochloric acid. Okay. This is taking a lot. And we could actually calculate, which I should have done with you guys. Maybe I'll insert that. We can calculate how much of this 1 molar that we're going to need, because the mole ratio is 1:1. So we can use our stoichiometry that we've been learning. I'm getting close. Can you hear it? Still reacting. As I swirl it around, the acid can get to more parts of the baking soda, and I can see there's like a pea-sized amount of baking soda there in the center, and I have a lot of water forming. The carbon dioxide is leaving, the water is forming, and I'm down to maybe like the tip of a pencil. I can see a little tiny bit of that baking soda there, and it's still reacting, so I'm going to give it a minute. Give it a little swirl. Make sure the acid can get to the baking soda that's in the center, because if it's in one big lump, then even if there is acid in there that hasn't reacted, it can't get into the baking soda. Okay, is that just a little bit more? Okay, I don't see any more baking soda, but if I add acid, there's a little bit more bubbling going on, so we're not quite done. We don't want that excess acid in there, so I'm adding it drop by drop until it stops bubbling. Still a little bit of bubbles forming. Maybe a couple more drops in here. All right, so I don't see any more baking soda. What we're going to do is we're going to put this NaCl in water. The carbon dioxide has left, and I'm going to put that onto my, that would be a big error. That'd be a big mistake, actually, if I spilled a bunch of this. So I'm going to put that on there, and we're going to go ahead and light the Bunsen burner, and we're going to heat it slowly. That means on a low flame. These haven't been turned on in a while. Take a second. All right, that is not a low flame, so let's adjust it. Turn it down just a little bit. Make sure that the paper towels are not too close. The periodic table is not too close. We'll put this acid towards the back, and we're going to heat that until all the water has boiled off, and we'll come back and check on it. Okay, I wanted you guys to see that the water, the salt water in the evaporating dish, came to a slow boil, and you could begin to see crystals of salt forming around the ring. And we're going to keep heating it until all of the water has boiled off. Okay, and we are down to the very end. We're heating it on a very low flame, and you can see that almost all of the water is gone. Just some last little bits that are trapped under the salt, and you can hear it popping a little bit. We did lose a tiny bit of salt out of the evaporating dish because the pressure of the water vapor underneath causes it to spit out. All right, so I've waited about 5 minutes for our evaporating dish to cool off, and now I'm going to use tongs I'm going to zero the balance, and we're going to see how much our evaporating dish with our NaCl inside weighs. You have to be very careful. There's salt all around. Oh no, these tongs are no good. I need a different pair of tongs. Okay, we're going to carefully take our evaporating dish that has cooled off, and we are going to put it on our zeroed balance very carefully. And we're going to record the final mass as 48.03 grams. 48.03 grams. And knowing the mass of the empty crucible and the mass of the crucible with our sodium chloride, we can use subtraction to find the mass of our salt.